Okay, fine. So let's do it. Implement queue using stacks. I'm giving this problem to you for reading for 2-3 minutes. Correct. Go to the definition of the problem and let me know what thoughts are there to solve it. Okay.
Yes, yes.
Giving to all of you to read the problem. Please go through it and then let's begin to solve it. Okay. All. Thanks. Any thoughts? Tell me. What are your thoughts? So typically inside this problem, I have to implement a queue using stacks, right? And what would be happening is first, again, whatever may be the behavior of a queue is, first element would be popped out from the overall queue. If any new element is coming, that would be appended at the end, right? That's how it's going to happen. And but this overall behavior, right, has to be implemented with the help of two stacks. That's what they have given us. Correct. I would be given two stacks exactly, and based on that, I have to implement the behavior of a queue. So push, pop, peek, and empty. These are the things I'm going to be implementing. Any thoughts how we are going to be doing it? Tell me.
Yes, we can solve this problem using either push or pop. We can solve big O of n. Like
Yeah,
suppose
definitely, definitely. Let me open my board. Let's try visualizing a little bit. And okay. So if suppose you are given two stacks, right? Implementation would be in terms of two stacks. Inside the overall working model, right, there are two stacks given to you. But what I need to do is, based on the two stacks implementation, behavior should be represented in terms of queue. Am I correct?
yeah.
This is what it should be happening. Okay, then suppose that. So how does queue behave? It says that whatever may be the overall data structure, new element X is coming, that would be put into the end, right? It would be enqueued at the end, and if something is to be popped out, that would be popped out from the beginning. That's how it's going to happen. Tell me that. The first element inside the queue, that would be popped out, correct?
Yes. Yes.
Fine. So let us suppose you are implementing the push operation and I have the pop operation as well, correct? So push, that means something is going into the overall queue data structure. Is it what it's happening? Push, that means something is going into the queue data structure. So let me just copy the data, sorry, the test cases from here, right? Suppose that you are having my queue, it's going to be push, push, peak, pop, empty. These are the things that I'm going to be doing, correct? And is it what implement queue using stacks? What does the peak element they are trying to notify from here? Okay, the front element of the queue, that's what they are meaning by peak. Correct, correct, no problem. Fine. Let's move on. Okay, then so there are first two push operations, right? Push one, let that be, then push, let that be two, and afterwards let there be peak, right? This is the operation that we are going to do. Whatever may be the front, return that. Then let that be, let there be pop, right? Let there be pop. Whatever may be the front, that would be going out, and afterwards let there be. Okay, fine. We'll check that later on, and we'll do accordingly. Yeah, fine. Let's move on. Let's move on, and let's see. By the way, peak, pop, and empty. Correct, correct. Move on. So let us suppose initially, let's have more push operations, right? Let's have more push operations. It's not that few elements with which push can be done. More operation would be apt. Let that be 3, let that be 4. Okay. So if an element first is going into the queue, what I can do in any of the stacks, let us suppose initially I would be entering my elements. Can I do it? Tell me that. In any of the stacks, let us have the assumption that this stack would be holding the elements currently for us. So first one would be entered into the queue. So let's stack one hold the element as of now. How do stacks are behaving? Whatever element you put, right? Let that be 1, 2, 3, 4. Every element has to be put at the top. That's how stack are meant to be there, right? Fine. So push one. So into stack one, let us suppose one is going inside. So at the bottom of stack, one is there as of now. Push two, two at the top of stack one. Push three, three at the top of stack one. Push four, four is at the top of stack one. So this is how inside the stack at its top constantly I am gonna be putting the elements. I would be inserting the elements. Then post that, what should I do? Now suppose the peak operation is coming up for you. What you are gonna do here? Remember, what is the peak? Peak means the front. Whatever is the front of the queue, you have to return that. Then accordingly, what I have to do? What are your thoughts? Tell me that, anyone? So see, what is the front of the queue based on the elements I have got? What is the front of the queue? Can anyone tell?
It's 1.
Okay, but this is residing at the bottom of stack 1. Am I correct?
Yeah.
This is residing at the bottom of stack 1. So how can I access that? Can you tell?
We can pop out all the elements
Okay, so one by one, I have to
one
pop
stack to
all the
another
elements,
stack.
right? One by one, all the elements needs to be popped. Then only at the bottom element, whatever is the first element that has gone inside my overall queue, that would be accessed and this would be returned. Am I correct?
Yeah, yeah.
Okay, but see, if I pop this out, right? If I pop these elements out, they are not to be deleted. I am popping out only to access one. It's not that 4, 3, 2 I am deleting because they are still part of the queue unless and until these elements are completely popped out from the queue. Do keep that into the mind. Then what should I do exactly? What are your thoughts? Tell me. What should I do? So let me do one thing. Let me do one thing. Whatever are the elements here, right? Inside stack 1, let me transfer them all one by one into stack 2. Can I do it?
Yeah.
Okay, 2 stacks, right? This has to be utilized anyhow. So whatever are the elements for me, let's start popping these elements from the top of stack 1. 4 has been popped out. It would be put into the stack 2. 3 has been popped out, put into stack 2. 2 has been popped out, put into stack 2. 1 has been popped out, put into stack 2. Can I do it? Can I do it? Now, what is the structure overall of stack 2? Tell me that. Is the front element coming at the top of stack 2? Tell me. Is it happening?
Yes.
Okay, so what I can do now, I can say, okay, inside the stack 2, whatever may be the top element, just return that. That's going to be my peak. So firstly, corresponding to peak, 1 would be my answer. 1 would be my answer. Okay, then if somebody asks you to pop, what will you do from here? Inside stack 1 right now, there is nothing, right? If somebody is asking you to pop right now from the overall queue, that means whatever may be the front element, just delete that from the queue. What you are going to do? Again, can I say into my stack 2, after the entire transfer has taken place, that front element is residing at the top. Can I say that? Front element of the overall queue is residing at the top of stack 2. I can just pop this out. Am I correct? Okay. Overall structure of the queue right now after inserting should be 1, 2, 3, 4. So 1 needs to be deleted. Where is it residing? At the top of stack 2. So I'm going to straight away delete this. Correct? Okay, then if again a pop operation is required, from where the overall deletions can be done? Can you tell me? Can you tell me? Is 2 again residing at the top of stack 2? Is it happening? Is it happening? At the top of stack 2 again is 2 residing. So I'm going to pop it. I'm going to pop it. Okay. Then again, if you are asked to perform pop operation, right? 3 should be the front. Where is it residing? At the top of stack 2? Pop. Correct? Typically, how I am managing the behavior of a queue is, suppose I would be utilizing stack 1 only for the sake of insertion. Only for the sake of insertion. Suppose that 1, 2, 5, 3, 6. These are the elements you wish to insert, right? So it's going to be 1, 2, 5, 3, and 6. These are the elements that has been inserted into the stack to implement the queue behavior. This is my front, right? This is my front. Overall queue, this element is my front. Now stack 2 is so far empty for me. Now somebody has asked you for either the peek or pop operation. Peek is there or pop is there. Anyone is there. I know at the bottom of stack 1, right? The peek, the front element of the queue overall is residing. That's what peek is going to be accessing. And if I wish to have the pop operation, this front only needs to be deleted, whatever is at the bottom of stack 1. So what I am going to do is that, fine, transfer all these elements from top to bottom into stack 2 whenever either of these two operation is occurring and stack 2 is empty. And the stack 2 is empty. Whatever elements you have into stack 1, transfer them all. So how the overall structure of my queue elements are going to be looking like right now? 6 would be whatever is the latest element that would be put to at the bottom of stack 2, correct? Then 3, then 5, then afterwards 2, then 1. See, right now into stack 2 after the insertion, what has happened? From front to the rear, right? All the elements are present from top to bottom. Is it happening? Is the structure coming well for us right now? Is it coming? Tell me that.
Yeah.
Once you perform the transfer from front to the rear, whatever element are present into the overall queue, their structure is maintained from top to bottom inside the stack 2. Am I correct? Now you perform peek. Whatever is at the top of stack 2, just access that, return. So 1 is my peek element. Somebody has asked you to pop the topmost element of stack 2 that would be going outside. Okay, again pop this element, whatever is at the top of stack 2. Again pop this, again pop this, pop this. Again stack 2 becomes empty. Again stack 2 becomes empty, and within while, suppose 7, 8, 9, these elements have been inserted into stack 1. So far, these all elements have been popped out. These all elements have been popped out from stack 2. Stack 2 has gone again empty, let us suppose. Then what you are going to do again? Tell. These 3 insertions more have taken place into stack 1. And the stack 1 is dedicated only for performing the insert operation into the queue. Okay. Then somebody is asking you again to perform the peek or pop. Then what you are going to do? Tell. What you are going to do?
Move all the elements.
All elements, right? All elements. So 9 would be here, 8 would be here, 7 would be here. Correct? All elements would be transferred to stack 2 and access the topmost element, return that, or straight away pop that, whatever is required. Okay. So see, insertion as per the enqueue operation or insert operation or push operation into the queue, push into the queue, I am performing into stack 1, right? No matter what element is getting pushed, straight away at the top of stack 1, it would be pushed for us. So that's a big O of 1 operation anyhow. Am I correct? Am I correct?
Yes.
Okay, now what would be happening? See, what would be happening when the stack 2 is not empty, right? You are trying to perform peek and pop. Straight away, the top element would be popped or accessed. Am I correct?
Yes.
So that's a big O of 1 operation only. But in the worst case, what would happen? Tell me. What are your thoughts? In the worst case?
In operation.
Yeah, in the worst case, when the stack is empty, that's the worst case, right? All the elements, all the n elements of stack 1 would be transferred to stack 2. Okay, would be transferred to stack 2, and then the topmost element would be either popped or returned. That's it. So that's a big O of n operation, but that is rare. That is actually not that frequent. Not that frequent. Definitely the worst case is still big O of n, but this is not that frequent. That's it. Okay, that's it. Can you try implementing? Tell me, will this implementation, can you try implementing this on your own? Will it be possible?
Yes.
So can I keep that as an assignment or should we code it together? Tell me what would you prefer? So
For me,
previous day stack using queues has been implemented by Vishant.
yeah,
Okay, fine. So this problem I'm keeping for your assignment, right? All the approaches and everything I have discussed. You code it on your own, correct?
okay.
You code this on your own. That would be exercise for you as well. For stacks and queues implementation. So it's two major problems on stacks and queues are done. Queues, there are not much problems, but this is only. Let's have some theoretical aspects of queue. Suppose that uh, somebody has asked you to implement a queue, right? Somebody has asked you to implement a queue with the help of an array. Then what you are going to do? This is an array overall. Let us suppose the maximum size what my queue can handle is 1, 2, 3, 4. Let's not make it that big, corresponding to 5 elements only. Okay, corresponding to 5 elements only, the queue can handle maximum number of elements, correct? And now if I ask you, utilizing front and rear only, I can store or delete the elements. This is what can happen. Am I correct? So once you declare an array of size 5, this is fixed. You cannot change it. Okay. So initially, suppose, how can I try implementing a queue with the help of an array? I can say initially my front and rear both are pointing to -1. They are not pointing anywhere because no element is there. First element you have to insert into the queue. Let that be 1. So front and rear both would be changing to index 0 where the first element is residing so far, correct? Okay, then suppose 2 you are inserting into the queue. Then what should happen as per this? 2 you are inserting into the queue. Then I think at the rear, right? Rear would be increased by 1 and at the rear position 2 would be inserted. Am I correct?
Yes.
Okay, fine. Then 3 you wish to insert. What would happen?
Increase rear.
Increase the rear and 3 would be put into the rear position. Fine. 4 you are trying to insert. Rear would be increased. It would be put here. 5 you wish to insert. Rear would be increased and the last element would be put to here. So right now I can just try saying that at this particular state, my entire queue is empty. Beyond this, I cannot put any element into the queue. Am I correct?
Yeah.
Okay, if you suppose wish to put any 6th element into the queue, then what this condition would be? If the queue is full, whatever queue I am having, it is full for me. And I am trying to insert the 6th element here. What this condition is called?
Queue is full.
Is it what we call as overflow? Is it what we call as overflow? Tell me that. Is it overflow? This condition, whenever this capacity of queue is full, because memory is empty, right? Sorry, memory is limited. Whatever RAM we are utilizing to store any of the element or perform any data structure operation, corresponding to data structure, a limited amount of memory would be given to you. So an entire queue can never be unlimited. It has some capacity. So inside the queue, right, whenever the entire capacity is filled, you wish to have more elements into that, it raises a condition what we call as overflow. Beyond this, no element can be stored. Okay, fine. Suppose a queue is empty. A queue is empty, let us suppose. Then what would happen? You are trying to delete from here. What we call this? Queue is empty, but you still wish to delete from here. Then what is this condition? This is what we call as underflow. Okay. Remember, this is eligible for both queues and stacks. Okay, this is eligible for both queues and stacks. Whenever from either of the data structure, their capacity is filled and you wish to insert here again, this is overflow. When both are empty, you wish to delete from there. This is what we call as an underflow condition. Both needs to be managed very well. Okay, are these concepts clear? First tell me that. Are these concepts clear to you? First tell me.
Yes, it's clear.
Okay, then. Okay, so let's move on and let's try, right? So I think already 5 elements are there into my queue, whatever I'm trying to implement into the, what should I say? Into the queue data structure. Front is residing here, rear is residing here, right? Okay, then suppose right now I wish to pop out the front element. Then what should I do? This is an array-based implementation I'm having corresponding to a queue, array-based implementation. Then tell me now what should I do? So size of the array cannot be changed. That's fixed. So can I just say one thing I can do definitely is put my
Increase
front to
the-
the next position. That's what I can do, right? Put my front to the next position. So literally right now, virtually I can try assume the elements into the queue are residing in between front to rear. Works. This element is still there, but no long in between front to rear. These are being virtually assumed to be part of my queue. Getting it? Okay.
Yep.
From the memory, since my array cannot be resized, arrays are fixed size. So definitely this one cannot be removed, but with the help of pointers, I can try the virtual deletion. That's possible. What's next should I do? Again, you wish to perform the deletion, take your front to the next step, and I can say 3, 4, 5. I can say just that 3, 4, 5. These elements are part of my queue, whatever is in between front to rear. Okay. Now
Now
tell me
we
for
try to add the element into the queue. What will happen?
okay. So tell me for exactly. I was coming to that point. Two elements are right now. Virtually, I can say virtual deletions for 0th and first index are done. Am I correct? Virtual deletion for 0th and first index are done. And for in between front to rear, these are the elements that are stored to me. Correct. So in this position, I think ideally we should be able to store more elements. Right. But how to do it basically? Suppose 6 you wish to insert right now. R would be put to R plus 1. And you are actually pointing to an index what the array is not supporting. Am I correct?
Yeah.
Am I correct? So what should I do? How can I say? Suppose that R is equal to n minus 1 for me, right? Where n equal to 5, size of the array, capacity of the queue, whatever I'm having. So if R is equal to n minus 1, I need to put that back to 0th index. Then what should I do? What are your thoughts? Right? R, wherever is my rear, the next available position is straight at index 0. Am I correct?
Yeah.
Am I? So here I should be able to access this index, and here I should be able to insert the element 6. Am I correct? So typically from front to rear, starting from the second index and back till the 0th index, my element should be residing. This is how overall I can try visualizing, right? How you can try taking it back to the 0th index. What are your thoughts? Can I just say whatever may be my R, right? R equal to R plus 1 taken mod with n. Will that work? 5 plus 1, sorry, 4 plus 1. It was already, my rear is already at n minus 1, right? Its next position would be R plus 1. Definitely, it should be ideally R plus 1, right? Take mod with n overall. So if it is already at the 4th index plus 1, 5, taken mod with 5. Is it coming equal to that of 0? Is it
Yes.
coming equal to that of 0? So I'm going to say shift your R to R plus 1 mod n. So R would be now pointing to index 0. Here I would be inserting 6. Try another insertion 7. Will the same formula work? Tell me that. R equal to 0 for me right now. Add 1. Take whole mod with 5. Is it coming out equal to that of 1? Is it happening? Is it happening? So R would be shifted to the next position. Here 7 would be inserted. Okay, right now I can try visualizing how the overall queue is looking like. It is present. The elements of the queue is present in between front to rear. In between front to rear. Right? In a backward direction, I can say. From 3, it started off overall, and it goes back till the rear. From typically till index 2. Sorry, index 1. Started from index 2, it ended at index 1. Any more insertion is possible? Tell me that. Any more insertion is possible?
No.
No, right? If you try again taking your R to R plus 1 mod n, then what is the overall thing we are getting? R would be pointing to 1 plus 1, taken whole mod with 5. Is it coming equal to that of 2? Tell me that.
Yeah.
2, right? It's next index, so it is going equal to that of front. Front is already having an element here. At this index, front is pointing, so front is actually pointing to the first element of the queue. Correspondingly, at the second index, if front is present here, that means already an element has been stored corresponding to this position. So this is giving me a condition that, okay, entire queue is filled. We are going to an overflow condition. So beyond this, I cannot go. So if we utilize all the indices of the queue in a circular manner, this is coming in terms of a circular manner, right? Then what kind of queue is it? Can you tell? What kind of queue is it? This is what we call a circular queue. Okay. This is what we call a circular queue. Okay. Is it well? And in terms of with the help of an array, we can definitely implement a circular queue. All the elements, all the indices of the array are efficiently utilized to store the elements. Okay. That's how we can do it. Fine. Is it clear? First, still how to implement circular queues.
Yeah.
So in general, in order to implement circular queues, in general, I can say take your R to R plus one modern. Take your R to R plus one modern. Okay, fine. Now, if I ask you, can the same thing be done for the sake of front as well? 6, 5, 3, 4, 2. Let us suppose this is my queue elements. Front is residing here, rear is residing here. Now, suppose perform the deletion from the queue. So front would be deleted. Am I correct?
Yeah.
Front would be deleted. Front moves on to the next element. Again, front moves on to the next element. If I perform another deletion, now what would you do? If you perform the deletion at the front, should the front be going back to the zeroth index? Should that be happening? So in between front and rear, right? In between these two elements, the overall queue elements are residing. Am I correct? So
Yes.
if you are performing a circular queue operation, right? Circular queue. Then overall, I can say move your front always to front plus one mod n. Correct? And rear also should be moved in terms of rear plus one mod n. This is a general formula utilizing which I can try inserting or deleting an element from a circular queue which has been implemented using arrays. Okay, linked list based implementation we'll see in the next iteration when we'll come to the topic of linked list. Okay, fine. Is it clear for everyone? Tell. Is it clear? Any problem? If you have any doubt, you ask me straight away.
Yeah, I have a doubt.
Yeah,
Uh,
go ahead.
Front is in last position. Okay.
Yeah, yeah.
Now we try to insert.
Yeah. So 6, 5, 3, 4, 2. Let us suppose this was the initial state. Front was here and rear was here, right?
Yeah.
Okay, then these from front to rear, these are the elements only. These are empty slots for us. These have been deleted. They have been virtual deletion, right? We cannot actually remove them due to the fixed size of array. We cannot actually remove them.
Yeah.
Then you wish to do what?
Yeah, got you.
So then you are going to be saying insert 7, let us suppose. So take your rear to the next step and update the element here to 7. Works?
Yeah.
Updation. This is virtually deleted, no longer exists. So I can update this, right? With a new value. Definitely. Okay, another insertion you wish to have, take your rear to the next step and just say that, okay, update the element here to 8. Can be done. Can be done. Okay.
Yeah.
At what condition I cannot insert any more element? At
That's
what condition you cannot insert any more element? What is that? Can you tell? What is the condition where I cannot insert any more element? Should I be saying that if r plus 1 mod n is equal to that of my front, then I should be raising the condition of overflow. Am I correct? No more elements can be inserted here. Whenever at the next immediate position of rear, front is present, at this particular situation, no more element cannot be inserted. If suppose why r plus 1 modern is definitely required, because there can be multiple situations, 6, 5, 3, 4, 2. Suppose rear is already here, front is already here. R plus 1 modern would straight away take me to the zeroth index, right? So at this condition, front is already occupying the zeroth index. I cannot insert anything here. This is giving me rise to a condition of overflow. All the elements have been occupied. In between front to rear, all the elements are present as a part of my queue, correct? There can be other situations as well. Circularly, if I just try visualizing, then I can say that suppose your front is residing here, rear is residing here, correct? So in between front to rear, right? These are the arrangement of queue elements for me. So at r plus 1 mod n, if I again take, this is taking me to the front index. Front is occupying the next position. So no element can be definitely inserted unless and until something from the front gets deleted. So this is what we call that, okay, whenever r plus 1 mod n, this is going exactly equal to that of front, then here no more deletions would be possible. I would be raising the condition of overflow. Getting it? Getting it? Is it clear? First still? Okay. Yeah. And then tell me for one. Suppose that you are having just exactly one element. 1, 2, 3, 4, 5 is the state of my queue. Suppose both and front and rear are standing here at the single element, let us suppose. Then what you are going to do in this case? Rest definitely from the array, I cannot exactly resize the array. That's not possible because that's a fixed size entity for us. But I can virtually delete. Suppose I can virtually delete, and in between front to rear, there is just a single element. Then what you are going to do in that case? Single element only. Now if I say delete this, now if I say delete this, so whenever front and rear are at equal position, right? That means they are just having single element into the queue. You wish to delete this, I would be just transferring my front equal to rear equal to -1. That means inside the queue, it is completely empty. I cannot do anything. When front and rear both point to -1, it is an indication that both your entire queue is empty, no element resides here. Okay, and whenever this situation arrives, and again somebody asks you to pop from the queue, you are to raise the condition of underflow, that from this particular state, no element can be deleted. Getting it? No element can be deleted. Are these points going clear? First tell. You have any doubt? You have any doubt? Then tell me.
No.
If you have, you can ask. These are some of the basic points of queue that you must know, right? If somebody has given you that implement a queue utilizing arrays, then this is how I should be taking up the entire problem utilizing 2 pointers front and rear. Okay. Is it fine? First tell. Is it fine? See here how we can try implementing this. Let's try. Let me just delete everything. There are more here. Let me just see. I think I need to go to some. Yeah, let's do it there. Here, no problem at all. Let's do it here. Correct. Okay, fine. What I require to do exactly? Can you tell? Firstly, I should be having a queue, right? So let us suppose in terms of array. So int and q, that would be an array, and let that be of size 5, new integer of 5, correct? In terms of arrays, I am implementing a queue. Then what should I do? Let's say that public static and void push into the queue, right? Void push. Here you wish to give few things. What is that? What is the overall queue I am having, right? And afterwards, where are the front and rear for me? Where is the front and rear for me? And afterwards, what else should I do? Tell. Where is the front and what element you are wishing to insert into the given queue, correct? Then what I need to check first, can you tell? Let initially there are no elements, so front and rear. Front is equal to -1 for me, rear is also pointing to -1. This indicates no element is there inside the queue initially. And yeah, then I say that, okay, push into the queue overall. Let that be queue and let that be the front and rear elements here. I wish to push element 1 into the queue, correct? Let's perform initially operation as correct. Initial operation, let that be 1, 2, 3, 4, 5. Okay, these are the things I wish to perform. Then next, what should I do? Tell. How to implement the push operation. First, check whether the queue is empty or not. Okay, whether the queue has any empty slots or not to be pushed. So I have to say that if. What condition should I check? What condition should I check?
If r equal to -1.
Okay, no. That condition is related to -1, that no element is there. But you are right now to push. So you have to check whether queue is empty, having any empty slot or not. So r+1 modern. Am I correct? r+1 modern. Well, I would be requiring size of the queue as well. Capacity of the queue, typically it's not. Yeah. r+1 modern is equal to that of front or not. Am I correct? This is what I need to check.
Yes.
This is what I need to check. If this condition is true, I have to put something. What is that? What is that? You have to say system.out.println, correct? Print overflow. No more element can be inserted because the next position is occupied by front. Already element resides there. Unless and until that is cleared, nothing can be inserted. Okay, then check. Else if r, the rear is pointing to -1, that means queue is empty. Then what should I do? Then suppose queue is empty. Then what should I do? I should be saying that r equal to, then I think r would be equal to that of 0. front would be equal to that of 0. And I think into Q's rear position, I would be inserting the element X. Can I do it?
Yes.
R is at -1. No element is there. So put both rear and front to the first element and just say that at the rear position of the Q, element X would be stored. That's it. Nothing else. Okay, what else? Okay, fine. Else what we may not do this, something like this. Okay. Okay, fine. We can do it. Else what should we do? Tell. Another condition. There are at least few elements into the queue, but definitely the queue has some empty slots. That is the last position. I can straight away say R equal to R plus 1 mod n. Am I correct? Mod n, correct? Put the rear position to the next available index, and at this particular index, Q of R would be equal to that of X. Done. Let the front remain in the position wherever it is already. Done. Done. I think the push is done. Okay, fine. What about your pop operation? How would you try implementing this? Tell me that. How would you try implementing the pop operation? First, tell me. Pop. Let us return the popped out element from the queue, whatever we are having. Its size, front and rear, whatever we are having. And we don't require any element X here, right? Because we are straight away popping out from the front and we are returning it. What
Check.
condition would you check here?
Check R equal to F. Front equal to rear.
Okay, firstly check what? R equal to -1 already, or I can just say, since the deletion would be from front, check whether that's it, whether that element is at -1 position or not. If it is at, then definitely Q is empty. I need to say that, okay, under flow condition it is. No need to delete. We cannot actually delete something from the queue. That's not possible. Else if R equal to that of front, right?
Yes.
If both rear and front are at the same position, only one element of the queue, then what should I say?
-1.
Let the element from the front be equal to that of Q of front. Then what to do? Let's first store that. And then, so let me just say that, let us have, because ultimately from the front only, we would be able to. So let me initially have the front value equal to -1, right? Such that it is an indication that no element initially into the front variable is there. Okay. So I'm going to be saying if front equal to that of -1, and then just print underflow. That's possible, or we can keep it to be void as well. No problem at all. No problem at all. Let's keep it to be void so that we can straight away print the front element from this function. Okay, then what we can say is that system.out.println. Println Q of front. This is what we can do, and then we can Q equal to -1, front equal to -1. Both of the elements got shifted to -1, marking that the queue is right now empty. Okay, then last, what should we do? Tell. If suppose more than one element is there into the queue, then how should I proceed ahead? Tell.
F equal to F plus 1 mod of n.
Okay, firstly print, right? Firstly, I have to print what? Okay, we can straight away say, we can do one thing. If this condition is not true, suppose if F equal to minus, okay, we can do it, no problem at all. We can first print the queue of front anyhow. The front element, what is it? We can print it, and then I can say front equal to front plus 1 mod n, right? This is what we can try. That's it. No problem, I feel. Am I correct? This is how we can try implementing push and pop operation. Let's try this. Let's try. So I think 1, 2, 3, 4, 5 from how the overall queue after this would be looking like. This should be looking like 1, 2, 3, 4, and 5, right? Let's see after popping out a few elements, how the overall structure looks like. Let us suppose I try popping out first 3 elements. Let that be pop, let that be pop, and let that be pop. Queue, front and rear, right? Anything else we would be requiring? Yeah, we require to perform, give them the size. It's going to be queue of capacity at max and not more than that. So here as well, I have given it. Okay, try running it. Let's see.
Declare n.
Okay, I'm sorry. Yeah, correct. It should be at int n equal to that of 5. Q cannot be converted to where we have actually made it. We made something wrong. I think, yeah, it should be a rear, not the queue. Yeah, fine. Where is it missing from our end? Let's check. Public static void, it's fine. Then again, suppose public static void, it's fine.
Trap.
Public trap. Okay, I'm sorry. This should be the main function. Public static void main. I don't know from where did it came up. Should be string args. That's how the function looks like. I feel right? This is the main function. Yeah. Try running it. Let's see. Underflow. Initially that came out. Why is it so? Didn't we move it? Why? Where did we make the mistake? What are your thoughts? Or didn't we push into the queue? Where is the mistake? What are your thoughts onto that? What are your thoughts? By the way, see for here, even if I am trying to, let us suppose here the front and rear should be changing, right? After the first push operation, am I correct? If you perform any push as per that, the front and rear variable should be having changed value. Am I correct? Am I wrong? Tell me that. Front plus rear. Is it happening at all? Let's try. Is it at all happening or not? Let's try that. So I don't think this is happening as per our current function call, right? This may not happen. Okay, so see for one thing, since the values are not getting changed at all, whatever are the initial values we have initialized, that's all it's staying as it is. How can I try tackling this?
Declare globally.
Okay, that's a choice. Anything else? Within the class, can I do something?
Yes. Within a class, we can declare it's globally.
So it's not it's a class variable typically, right? It cannot be something that is what we call as global. So I can just say static variables, like we can static int and let that be front, that would be -1, and what? Static int front would be and rear would be initially -1. Can we try that? Right. So let everything be as a part of class variable for us, right? Let nothing be there. Static. So let that also be static integer array. And afterwards, let that be static. What is it? Anything we have missed? Static int n equal to that of 5, right? This is what we can try out. So I think into the pop operation, we won't be at all requiring any value. Am I correct? Just a single pop it would be. And I would be just requiring the value to be inserted, that is x, and rest everything should be getting handled on its own. Typically, I don't require any values to be passed, just the value I need to put into the queue. Let me try like this. Okay, after the pop, nothing should be required. Let me try. Is it coming well for us? The first elements to be popped out is 1, 1, 2, and 3. Is it coming well?
Yes.
Is it coming well? But why they, okay, fine. This is corresponding to this FNR, right? Which is not required at all. Okay, it's coming well, right? 1, 2, and 3. What if suppose before pushing anything, I try to pop out from the stack? Will it work? It should be giving me a underflow, right? Let's check those conditions as well. It's an underflow, correct? And even after, suppose we have pushed all the 5 elements, push 6, try running it. So it's an overflow. All the conditions are working well, right? Well enough. I'll push the code, right? All correct. Is it understandable fully how the queue is working? Tell me that.
And size of the stack, queue.
Where is it?
So we need to show size of the queue, right?
When do you need to show that? Okay, how many elements are there, right?
Yeah. How many elements are?
So how can you trace that with the help of front and rear? Tell me. In between front to rear, there are elements. Tell me that. How you are going to trace it, by the way? How we can do it? What are your thoughts? Okay, suppose that there are conditions. There are conditions here. What I should say is that, okay, so let's have multiple conditions, right? Front can be before rear. First, front can be before rear. So in between front to rear, there's going to be elements for us. Am I correct?
Yeah.
And there are overall n elements here. Suppose that front is residing at 2, rear is and n is equal to 7. Front is residing at 2, rear is residing at 5. Okay, remaining how many positions are empty for us? 1 is 0, 1 is empty, and 6 is empty, right? These three elements are empty. So how to trace that in between front to rear? How many elements are there? How you are going to trace that? How you are going to trace that? As well as there is yet another condition. Rear would be here, front would be here. Front would be ahead of the rear as per the circular queue terms. Again, it is in 2 and 5, and then how you are going to trace accordingly? What are your thoughts? Distance between front to rear. What is the distance between front to rear? It's positive value. If I have positive value, how to calculate that? Tell.
Absolute. Use absolute. We can.
Yeah, using absolute, the distance between front to rear, I can just say it's equal to 5 minus 2 plus 1. Can I just say that?
Yes.
5 minus 2. Okay. Then corresponding to this also, the absolute value, if I try to have positive value, it's going to be again 5 minus 2 plus 1. Both the conditions are different here. Right now, in the first condition, in between front to rear, I have elements. This is the actual region which is occupied with elements. Am I correct? Am I correct? Whenever
Yes.
front is lesser than equal to rear, right? In that situation, whatever the overall val I got, this region is occupied with elements. So this is the actual number of elements for me. Am I correct? This is the actual size of the queue that I am having. Am I correct?
Yes.
And whenever rear is this, whenever suppose, what should I say? Whenever rear is before lesser than equal to front, right? Whenever this is the condition, then what you are getting here? From front to rear back, right? From front to rear back, we don't have elements. From front to rear, we have elements. This entire in between r plus 1 till f minus 1, right? This is the region which is empty, which does not have any elements. So what is the size of this region we can have? Tell me that. F minus r plus 1, am I correct? This is the region which is going empty. So how many elements? This is the empty region for me, empty, no elements here. So how many elements are occupied? N minus this, can I say? Can I say this is the size of my queue, whatever I'm having? Can I say that? All fine. In the first condition, in between front to rear element is residing. So how many elements are there in between front to rear? Straight away, whatever may be the index of rear minus front plus 1. These are the actual elements or size of the queue, whatever I'm having. If suppose rear is lesser than equal to front, that in that sense, I have to say, okay, the region between r plus 1 to f minus 1, this is a region of empty elements. These regions are not occupied at all. How many elements here? I can straight away say this is nothing but f minus r plus 1. Okay, f minus r plus 1, straightforward. Subtract that with n, then size of the queue I would be having. That's it. Works? Works? Tell me that.
Yes. But we can trace using another variable like size.
Can do it. Definitely you can do it. But if suppose you are not tracing, utilizing this formulation, you can straight away calculate. No problem at all. Okay. If you are not doing it, then utilizing this formulation, you can do it. Or you can straight away do, you can maintain a size, right? Capacity we already have in terms of n. You can maintain the size. Let that be initially 0 and you can keep on decreasing and increasing it. So I can just say whenever these two conditions are done, right? I can, if suppose it is going, if the stack is going empty, then it would be 0. Size would be 0, or else here it would be size minus minus. Correct? Anyhow. If suppose we are going for the insertion, then into the push I can say size plus plus and size plus plus size plus plus. In both the situation I can go ahead. That also works very well.
Yeah.
Okay. So yeah, that's all about a theoretical aspect of queue. I think major problems of the queue we are already done. Tomorrow, two more problems and I'm going to be introducing to you people. One is a combination of queue with hash maps, dictionaries. Sorry, yeah, hash maps. Another one is how to go ahead and implement the sliding window maximum or minimum utilizing queues. Okay. Fine. And I think mostly the queue related problems would be done for us. Nothing much is there, to be very honest, inside with queues. Anything more you wish to ask? Tell me. Any doubts? Any more doubts you people have? Tell.
No doubt it's clear for me.
Okay, then let's continue from tomorrow. Let's wrap it up here today. Downloaded the code. We'll push that for you people. Okay.
Yeah.
Fine. So tomorrow, same time again, we are going to go ahead. And tomorrow, hopefully, queues part would be over. Next week, the linked list part will start. Okay. Vishant will be taking your first class for linked list again Friday, 9 p.m.
Yeah,
4 or
thank you.
5 classes for linked list max, not more than that we would be requiring. And it would be done. Okay then. Thanks all.
Thank you. Thank you.
Yeah, thank you. Able to understand everything? Tell me that.
Yeah, it's clear. Concept is clear and implement the queue is clear for me.
Okay, great.